Hello everyone, so in this video we are going to solve a question of Leetcode, that is an array tree level order traversal. So let's start with the problem statement. Given an array tree, return the level order traversal of its nodes value. So basically in this question we have given a tree and we need to find out level order traversal of this tree, right? So basically in this question this is a simple level wise order traversal question, but the tricky part is we do not have any left or the right children in this tree, right? So in place of this left and right pointers we have basically given a vector of pointers, that is children. So we just need to modify our code. Rather than pushing the left and right children, we need to push all the values from this vector of children, right? So let's quickly see how can we approach this question. So before that, let's first take the first example. So this is the first example, and if we find out the level wise order traversal of this tree, so the level wise order traversal of this tree would be the first level will give us 1, then the second level will give us 3, 2 and 4, and the third level will give us 5 and 6, right? So we basically need to return our answer in a 2D vector of this would be the first vector, this is the second vector, and this is the third vector, right? So we basically need to return the answer of these three vectors, right? So I hope this example is clear to you. Let's quickly see how can we approach this question. So to approach this question, we will be using a classic BFS approach, and that BFS approach will give us the level wise order traversal. So the thing we need to modify in this level wise order traversal is to replace the pushing of left and right childs with the traversal of this children vector, right? So let's quickly see how can we modify this. So let's say we take a queue, because in the level wise order traversal of BFS approach we take a queue. What is queue? Queue is a data structure which follows first in first out property. This is a FIFO property, which means that the input, or we can say the node which is inserted first, will be popped out first, right? So this is the first in first out property. So we will first create a queue, and in this queue we will initially push the root of this tree, right? So the root is 1. Now after pushing this root, we will be checking this root, right? So when we will be checking this root, so for this root we will just traverse through this vector, right? This children vector. So for this children vector we will get 3 more nodes, right? We will get 3 more rows. So in the binary tree, what we usually do, in the binary tree we get left and the right child, but in this tree we have given an array tree, right? An array tree. So it means it can contains n number of children, right? So what we can do is we can traverse through this vector and push the elements into this queue, right? So let's say this is the first level, so we will just store this somewhere. So let's take a vector of vector, let me write vv, and for this first vector we will take 1, right? For this first we will take, this is the vector 1, and we will just push 1 into this, right? And for this one we will be inserting the second level elements, and the children of this one is 3, 2 and 4. These are the 3 children of this, which we will be getting through this children vector, right? So after this we will just pop out this one from here, and we will get these 3 elements, right? Now we will just traverse through these 3 elements, or we can say these 3 nodes, right? So for each of the node we will be getting the new values, right? Or we can say the new values from this vector. So for this 3, when we will check for 3, for this 3 in the vector we will get 5 and 6. So we will just push 5 and 6 here, right? And this 3 will be popped out from here, and we will just push this 3 into a second vector, because this is a second level, right? So just push 3 here. Now we have 2. For this 2 we do not have any children, so in this vector we won't be having any node as such, so we will just pop it out from here and push this to this vector. So 2 will be here. Now for this 4, again we will check, we don't get anything from here, so we will just pop out 4 from here and push 4 to this vector, right? So we have just completed the iteration of this second level. Now we come to the third level, right? So for this third level we have 5 and 6. So for this 5 and 6, first we will check for 5. We don't get anything, like we do not get any children of this, so we will just pop out this from here and push this into the third vector, that is 5. And for this 6, again we don't have anything, so we will just push this here, right? So at the end we will get a empty queue, and whenever we will get an empty queue, we will just exit from this while loop, and at the end we will get these three vectors, right? These three vectors. So this we will be returning as the vector of vectors, or we can say the 2D vector, right? This we need to do in this question. I hope this approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Let's move to the coding part. So let's first create a queue of nodes, right? Because we will be storing the nodes in this queue, and also check whether we have any element in this root or not. So for this, let's check if root is not null, right? If the root is null, then we will be just returning a empty array from here, right? Now let's push the root initially. So let's push root from here. Now let's run a while loop until this queue is not empty. So queue is not empty, and now let's take a temporary pointer here which will be pointing to the current node. And before that, let's first run a for loop for each level, right? We need to run the for loop for each level so that we can traverse for each level individually, right? So for this, let's take a integer variable int n is equal to q dot size. This will be storing the size of each level, and let's run a for loop for this to traverse through all the nodes of a single level. So int I is equal to 0, I should be less than n, and I plus plus. Right, now let's take a temporary node here, and let's take the current node. So q dot front, and let's pop it out from here, right? And also take vector and a vector of vector for the answer. So let's take a vector of integers, and let's name it answer, and also take a vector level so that we can store all the elements of a single level in a vector, or we can say a 1D vector, right? In a 1D vector. So let's take a vector here and let's push the values into this. So level dot push back temp value, right? And let's, now this is the main point here, we need to just modify this level wise order traversal, or we can say the BFS approach from the classic BFS approach, right? So this is the new statement we are adding here. The new statement is we need to traverse through this vector, right? We don't have any left and right pointer in this, so what we need to do is we just need to traverse through this vector rather than traversing through, or we can say rather than checking for the left and right child, because we do not have any left and right pointer here, but we have a vector of pointers here which will be storing all the children of this current node. So we will be just traversing through this. So let's run a for loop for this. So for auto x, and let's check for this current, that is a temporary one. So temp children is the name of this vector, right? Now for this, let's push all the values into our queue. So q dot push x, right? At the end, just push the value into this answer, right? So in this answer, let's push the level vector, because we have stored all the elements of a single level into this level vector. So push back level, and at the end just return answer from here. Alright, I hope this is fine. Let's try to run this on the sample test cases. Yeah, it's running fine. Let's just submit this. Yeah, it's working fine. So the time and space complexity of this solution is bigger of n, because we are traversing through all the n nodes, and the space complexity of this approach is bigger of m. We can say m is the maximum number of elements in a single level, right? So let me write it here: maximum number of elements in a level. Alright, so I hope this approach and code is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.